again. So in previous video I discussed some basics of trigonometry. So basically what I said in that video was, in any right angle triangle, the side opposite to 90 degrees hypotenuse represented by h, and if this angle theta is our angle of reference, then in this triangle the side opposite to the angle of reference is considered as perpendicular p, and the rest of the side, the only remaining side here is this one, and this is considered as base. Now with respect to this, we defined some trigonometric ratios by sin theta given by p by h, cos theta b by h, tan theta p by b, and similarly their reciprocals, cosec theta h by p, secant theta that is h by b, and cot theta that is cotangent of the tan theta that is b by p. So now this idea of trigonometric ratio, this concept can be used in another problem solving type. Here we deal this in engineering purpose also when dealing with the leveling or finding height of different levels on earth surface. So trigonometry is used there. It is called trigonometric leveling there. So I'm not going to go into that dimension of engineering and all those things. So simply what I will do is, I will help you use these trigonometric ratios to find unknown sides in real world problems. Unknown real world problems simply means real world problems are first they are transferred into some triangles and different shapes here. Especially we deal with right angle triangles here when we talk about height and distance, and then we solve the problem accordingly using the concept of these trigonometric ratios. So let's see that. So let's take a problem here. So in this problem, this is the problem. At the foot of a mountain, the angle of elevation of the top of the summit is 45 degree. So now this is the problem here. This is the case of real world. So we are talking about mountain, but what we'll do here is we will make triangles out of it. We consider mountain as standing erect at 90 degree with the surface of earth. Similarly, different types of other problems dealing with buildings, poles. So all these physical structures, they stand erect at 90 degree with the horizontal surface of the earth. So we'll consider that. So before going into this, first let's understand what angle of elevation and what angle of depression are. So let's go there first. So let's consider here. Now see here, we know that we can only view object in straight lines. So that means light do not travel in curved path. So we are not going to talk about bending of light and Einstein here. Generally the light propagates in the straight line, and we call it rectilinear propagation of light. So this straight line, along this line we view the object. If any object is here, so we can view this object in the straight line only. So this is called line of sight. This is our line of sight here. Now any line parallel to the surface of earth, so this is horizontal line. This is called horizontal line. Now what happens if something is above the horizontal line? If any object, if we are viewing any object which is above the horizontal line, what happens? Angle of elevation is formed. This angle is called angle of elevation. So if you are viewing any object above horizontal line. Now similarly, so this is our horizontal line here. So any object is here, you are viewing any object below horizontal line, so we'll consider our eye, the placement of eye is here. So we are viewing this object, so this is our line of sight here. Now the angle between this horizontal line and line of sight when you view an object which is below horizontal line, so in that case we call this angle as angle of depression. So these are the concepts here, so we need to understand these concepts so before solving the problem. So now let's go towards the problem. So now here is our problem. At the foot of a mountain, so what we'll do is we'll consider there is a mountain and which is erect at 90 degree with the surface of the earth. So let's draw a straight line here. So let's draw the straight line, horizontal line. So this is the horizontal line or the surface of earth. So mountain is standing here. Sorry, this line is not good. So where are the lines? So this tablet version is not very good. So I'll try to draw here. Let's consider this is erect here. So this is the mountain, this is the top of the mountain here. This AB is the mountain, this is the vertical height of the mountain, and A being the summit of the mountain. Now according to this problem, at the foot of the mountain, the angle of elevation of the top of the summit, so this the top point here is 45 degree. Angle of elevation means we are looking upwards. After ascending 1 kilometer up towards the mountain at an inclination of 30 degree, the elevation changes to 60 degree. So what question is saying is, suppose the placement is here. Now what we are doing is, from this foot of the mountain, now mountain it can be like this, mountain is going like this here. So consider this is the foot of the mountain here. Now from the foot of the mountain, we are looking the top of the mountain here, we are viewing it. So this is little bit not good, so let's make it even. So the mountain is like this, consider it this way. Okay, now point C is the point from where we are viewing the top of the mountain here. The question is saying that the angle of elevation of top from this point, the foot of the mountain, is 45 degree. So from here to here, so this is along the straight line we'll observe. Now this angle here is angle of elevation, and this angle is given as 45 degree here. Now in the another part of the question, after ascending 1 kilometer up towards the mountain, so maybe it is a little bit like this. So you put another point here, take this another point here. No, so let me clear this. How to undo this? Okay, so this is the top here. Now after ascending 1 kilometer towards the mountain, now from here you ascended 1 kilometer from here to here, maybe at an inclination of 30 degree. That means the angle here, it is 30 degree only, 30 degree. The elevation changes to 60 degree. That means if you observe again the top of the mountain from here, it is 60 degree here. So the picture does not look good, so I'm going to make it once again. So this is the mountain. It is very difficult to draw the straight line here. So this is the mountain here. From the foot of the mountain, if you observe the top, the angle of elevation is 45 degree. Now if you move towards the top of the mountain, so this AB being the vertical height of mountain, C is the foot of the mountain. Now move 1 kilometer towards the mountain, means from here at an inclination of 30 degree. So you make 30 degree angle, move some point here up to some point here. Now from here you observe the top of the mountain once again, and you realize this angle is 60 degree here from that point. So initially when you observe the top of the mountain, the angle of elevation of the top is 45 degree. Now you moved 1 kilometer, so let's name it D here. So this CD is 1 kilometer here. So from this point you stopped here and you observe the mountain again, the top of the mountain, and you found that the angle of elevation changes to 60 degree from 45 to 60. Now question is saying us to find the height of the mountain here. So let's continue with this. So let's draw another line here. So this is perpendicular, so vertical height of the mountain is also considered 90 degree there. So let's write few things here. AB, it is vertical height of the mountain. Now we don't know, so we'll consider this height as h. If you consider this height as h, so equal to h, say it. So we are going to suppose this is h. Now this height CD is the distance along the mountain, because you ascended along the slope, so that is the distance, slope distance from C to D, slope distance from foot, that is C, to D, that is 1 kilometer here, that distance here. So now we have to determine the height of the mountain. Now how to determine? Now that is the problem here. So let's play with this diagram. So we are observing some right angle triangles here. So this is one right angle triangle here, this triangle is right angle triangle here, this is right angle triangle, this one triangle is right angle triangle, and I can see another right angle triangle as well. So it is here, this is also right angle triangle here, this is another right angle triangle, and I can see a rectangle as well. So here is rectangle, so this is the rectangle here, another geometrical figure which I can see is rectangle. So now we'll try to solve this problem. So we need to find the height AB of the mountain, and here's another right angle triangle ABC. This big triangle is also a right angle triangle. So let's see in that triangle first. In right angled triangle ABC, here ABC, so we have 90 degree at B here, so obviously AC is going to be hypotenuse here for that triangle, and we have tan 45 degree. So let's take tan 45 degree. Now in this triangle ABC here, this is A, this is B, this is C here, this are 45 degree. So here 90 here, so this is going to be hypotenuse. So from our angle of reference is this one, so this is going to be P and this is going to be B. So tan 45 being perpendicular by base. So what is our perpendicular? So it is AB here divided by base is BC. So the value of tan 45 degree is 1. So we have to remember some basic values of trigonometric ratios. Let me explain that as well. So there is easiest way of remembering this one. So what we'll do is we write here 0 degree and then 30, then 45, 60, 90. Now what we'll do is we'll write here 0, 1, 2, 3 and 4. So we divide all these numbers with 4 and then we put all of them inside the square root here. Now 0 divided by 4, so what comes out at last? 0. From here 1 by 2, from here 1 by root 2, from here this what comes out is root 3 by 2, and here we get 1. So what we'll do is we take sine here first and then cos, and then we take tan here. Now sine 0 degree, its value is 0 here. Similarly sine 30 degree, its value is 1 by 2. Similarly sine 45, its value is 1 by root 2, sine 60 is root 3 by 2, and sine 90 is 1. So these are some basic standard angles whose values for different trigonometric ratios can be found very easily using this method. Now cos theta, what we'll do is we'll interchange the values for complementary angles. 0 plus 90 is 90, so sine 0 is 0. Similarly cos 90, so for cos 0 the value of sine 90 will be taken, so it will be 1 here, so bring this value here. Similarly root 3 by 2 and then 1 by root 2 as it is, and then here 1 by 2 and then 0. So here for tangent, tan theta being sine theta by cos theta, we simply divide this. 0 by 1 is 0, 1 by 2 divided by root 3 by 2 will give you 1 by root 3, and 1 by 2 divide this, you will get 1, and here you will get root 3, and 1, any number divided by 0 is undefined. So this is how we get different values for standard angles for different trigonometric ratios. So this is the easiest method I use to remember the values, and once you remember, it is not very difficult. You can memorize these values. So we'll use tan 45 degree. Now for tan 45 degree our value is 1, so we make use of this. So here tan 45 is 1, so here AB is H, so BC, we have not supposed anything for BC, so BC equals to H. So let's consider this as relation 1. Now let's see this diagram and continue further. Now see here, we have to find the height here. So now see here, what we'll do is we'll take triangle, name this as E. We'll take right angle triangle CDE, this light blue colored one, cyan color, better to see that cyan color. So let's take triangle in triangle CDE, in triangle CDE. So this is right angle triangle here. So this angle is 30 degree because question is saying the inclination of 30 degree. See here, the inclination of 30 degree. So we'll take again, now this CD, we have CD, so side opposite to 90 degrees 1 kilometer, so hypotenuse is none, and we need CE here. So what we'll do is cos theta is better here, so let's take cos theta here. So cos 30 degree, now base by hypotenuse. So for this reference angle, perpendicular is DE, base is CE, so let's divide CE by hypotenuse in this right angle triangle here. So this is our right angle triangle, this is 1 kilometer, this is 30 here, this is C, this is D, this is E. So in this triangle cos theta will be simply, and here it is 90 degree, cos theta is going to be base, that is CE, divided by hypotenuse, that is CD. Now what is the value of cos theta? Now we'll use the table here. Now cos 30 degree is root 3 by 2. So let's take that. So here we have root 3 by 2. And this CE we don't know. CE as it is. And CD 1 kilometer given. So after cross multiplication we get that CE is simply equals to root 3 by 2 kilometers. So this is the side or the length of CE. Now what we'll do here is, now we try to find H. Now how to find H? Now we have to determine another thing here. We have to determine the CD also. We must be able to find CD. How to find CD? So not CD, sorry, ED. So ED can be found similarly again in triangle CDE itself, same triangle. So if you consider sine theta, so this is sine 30 degree, we get this is P by H, so this is ED divided by CD. So its value is 1 by 2 from the table, and ED is ED, you don't know, CD is 1 kilometer. Now simply we get that ED is equals to how much? 1 by 2 kilometer. So the height ED is 1 by 2 kilometer. So now we have to find the height. Now see here, an interesting thing is going to happen here. Now in this triangle, so see here, this distance we calculated this to be, where is it? Okay, here, root 3 by 2 kilometer. So this distance here is root 3 by 2 kilometer here, this distance. And this whole distance is H, because already we found this BC is H here. Now this vertical height here, this is 1 by 2 kilometer here, this one. So here this is also 1 by 2 because this is a rectangle. Now this whole height is H here. So what we are getting for this one is, this is H minus 1 by 2 kilometer here, this height. And this one, the distance from here to here is H minus root 3 by 2 kilometer from here to here. So what we'll do is, we will see triangle AD, what is its name is not here, M. Let's consider this M in triangle ADM. So let's write that one. In right angle triangle ADM, in right angled triangle ADM. So here ADM means here ADM in the diagram. So M is here, this is M. So what we have to do is, we simply take tan 60 degree here. Tan 60 degree is going to be P by B, that is AM by MD. AM by MD. So tan 60, if you go to the table, tan 60, its value is root 3 here. So let's put root 3 here. So its value is root 3. And AM, from this diagram we see AM is H minus 1 by 2. So H minus 1 by 2 here. And MD here, MD is H minus root 3 by 2. This distance here MD, H minus root 3 by 2. So this is H minus root 3 by 2. So now let's do simple mathematics here. Let's cross multiply. This is root 3, so H minus root 3 by 2 here. This is equal to H minus 1 by 2. Or, so now let's open bracket here. This is root 3 H. So minus root 3 times root 3 is 3 by 2. And this is H minus 1 by 2. So, or, now bring H this side. So this is root 3 H minus H. Now take it to another side. It is root 3 by 2 minus 1 by 2. So it's been common. So this is root 3 minus 1. And this is 3 minus 1 by 2. So what we are getting here is this 3 minus 1 being 2. This is 2 by 2. And then this root 3 minus 1 goes here. So this 2 is cancelled out. So 1 by root 3 minus 1. So this much kilometer. Now if you want to convert this into decimal, so we have to use calculator. So let's go for calculator and let's find it. Where is the calculator? Okay, so so this is 1 divided by root 3 minus 1. So root 3 minus 1. So 1.366. So the value is 1.366 kilometer. So this is the height of the mountain here. The mountain is 1.366 kilometer tall. So from the horizontal level, the top of the mountain is at the 1.366 kilometer. So this is how we use the concept of elevation and depression angle and concept of trigonometry, different trigonometric ratios here, and the idea of right angle triangle. Principles, different principles are Pythagoras. Sometimes we may have to use Pythagoras theorem as well. So this is how we use our concept to solve the problems. So this is the way of finding height of or unknown side of the triangle. So we are dealing with triangles here. So this method is also used in leveling purpose in in civil engineering. I think leveling, there is a topic called leveling, and they study about trigonometric leveling. So this is the concept required there. So if you are clear about this concept, it will be very, very helpful to you in solving such kinds of problems. I hope this is helpful to you all. Thank you for watching my video.